Again, let's highlight the topic we're doing. This is the atomic structure and the periodic table. I'm not seeing much of the atomic structure just yet, but certainly the periodic table is here. And yeah, just remember which topic they're focusing on here. All right, so them say compare two of them in terms of that. No, it's interesting. The magnesium is up here, and X is down there.
Magnesium is probably the easier for ionization.
Why are you saying that? you just feel like it's the easiest?
Well, what is X, sir? That is the question.
No, then you say you're not required to identify X. That's not the question. Yeah, that's not the question. The question is where and all right? Because why is magnesium up at the top there and why is X down there? There must be a reason why X is lower down. You know what I mean? So I don't know. So for example, let me ask it another way then. Why all right, so when you guys wanna be seating for exam, like when we seated for exam, and they call the name alphabetically, all right, why does Deborah name appear before Gennari's name?
Because it come before, sir.
So because the C comes before R.
C come before R. Yeah.
D.
So,
Sir, both letters as well, the D and the C. But they normally do it by the surname.
a surname name use. So yeah. So there's something about magnesium why it is before X. So what is that?
So X would be more likely the E's.
No, you can't say that just so. I mean, you can't be guessing that. You have to be able to tell me why magnesium is up here and why X is down here.
Sir,
And
because
yes, Shantae.
Is it because it has less electrons?
Well, no, you're talking. No, you're talking. Hope everybody heard that. Magnesium have less electrons. Yeah. Benito saying it's atomic number. Well, okay, fine. So, so you're saying magnesium has less electrons. All right. Yeah, that's a good start. All right. So X has more electrons than magnesium. That's what you'll be saying, Shantae, right?
Yes, sir.
Yeah. So all right then. We can work with that. So then where are the electrons? So the electrons that Mg or magnesium have. Where are electrons found, by the way, on these atoms? Which part of the atoms are electrons found? That's a better question.
On the shells.
Yeah, Shantae is saying the shells. Benito's there texting shells as well. So if I got that, Casey?
Sir, I was saying it, but you me some water. Sir, you must see me come back, the reverse.
Okay, all right. So I was wondering what's happening to the class here. All right. So electrons are found on shells. All right, we definitely are on the same page there. So then does more electrons mean more shells?
Yes, sir. Well,
depends
on how much shell it can how much electron it can hold per each cell, sir. So it would get more. Yes, sir.
More shells. All right then. So basically then, this is the question I'm going to have to ask then. All right. Let's ask this now. Who is more likely to donate to charity? A rich person or a poor person?
Rich people,
Rich.
because they have what to give.
They have what to give. And this is the case of magnesium here. Magnesium has a few electrons. X has more than magnesium. Right? So these atoms in the first row are very poor atoms because they don't have much electrons there. But going down, these columns here, X definitely will have more electrons to give, and so if it have more to give, it's easier to give away. And that's the thing there. So compare Mg and X in terms of ease of ionization. The idea is that you'll have to say why. If you're gonna say X is easier to give up electrons, you're gonna have to say why. All right. Now, see, part one give you some space to write. All right, ease of electrons. You're getting how much marks we see? This look like 3 marks. Here's one for saying which one would be easier, and then 2 marks to explain why. All right. So should I write that is magnesium that will easier to ionize, or is the other way around?
Magnesium will probably be easier to ionize.
Okay, so then are saying magnesium is easier to ionize because it has less electrons to give away, so it would want to give it away. That's what you're saying? Going back to the same question that I asked before.
X is down at the bottom, so
Yes. So why is it down there?
because
Because what?
opposite away girl is, sir.
Hold on.
I don't remember what she said, sir. She said something about less and
Right.
less electrons or something. I don't know.
We underline periodic table. Periodic table, all right, divide into 2 parts. All right. One part is the column. The other part is the row. So what name do we give to those parts of the periodic table?
Period.
Period of groups.
All right. So we have a period and we have our groups. All right. So if we know our periods in the periodic table, we know that sodium is actually period 3. And the next column would certainly be, our next row would be period 4. And this would be period 5. What place, what puts our let me see now. Why are elements placed in periods?
Sir, to show the amount of shells that they have.
Very good. So it's the amount of shells. So period 3 elements have 3 shells. Everybody get that?
Yes, sir.
All right. So period 5 elements going to have how many shells?
5.
5.
Yes. And then we're seeing something happens. What happens to the size of the atom when you add more shells?
Yeah, bigger, sir.
Yeah, get bigger. So if you are a bigger atom, can you watch all of those electrons? Can the element watch over them the same way as when it's small? If your yard big, can you see everything that's going on in the yard? If the yard is very big. I mean, I'm assuming that. Yeah, I'm assuming that with we're talking about like probably Devon House, and so them big houses where the Prime Minister live, and so is the Prime Minister able to see without a camera what is happening in around the yard?
No,
No, sir.
No. All right. But if you live in our ghetto in our little zinc cubby hole, can you see everything that's happening in the house, in the yard?
More sight, sir.
More sight you can see. That's the idea. So magnesium has, it has more control over its electrons. So it's not gonna lose them so easily. So that's how magnesium work. But hold on there. I'll get ready to share by you. But by no start till by no start it, you know. All right, anyway. So we have 5 shells here for X. Magnesium will have 3 because it's in period 3. So as a rule, as the number of shells increase, it becomes easier for elements to lose electrons. Notice, easier to lose electrons. Everybody get that?
Yes, sir.
That's all the explanation you need. The atom get too big and the electrons them too far away from the nucleus, so them can't hold on to the electrons. And electrons are lost from the outermost shell. They're lost from the valence shell. So that's the explanation here. So the argument now is that X will lose electrons easier than Mg. Explanation? And
So if you lose electrons, that would be the ease of ionization.
it's just how easy it is to happen. That's how easy, how likely it is to happen. That is what the sentence is saying. So all right, explanation for this now is that as the size of the atom increases, then the nucleus cannot hold the electrons. It can't
Doesn't
hold
have
it.
enough control. I could say enough control.
Yeah, I said control, but
Oh,
that's
yes,
like
sir.
a street talk, really. Yeah, it can't really pull them in, then that's a better term to use. So all right, so there's this explanation because X has a larger there's so many ways we could explain this. I'm trying to think of the best way.
Larger shell.
No, not shell. This is the term.
The
Yeah, larger radius, yeah, than Mg. So larger radius mean like, you know, bigger size here than Mg. All right, so then the nucleus has less pull on the outermost electrons. Yeah, outermost electrons of X. All right, but you see that?
yes, sir.
All right. So all right. So guys, as we say, in reality, no element wants to gain or lose electrons because the number of electrons we make with is equal to the number of protons that it was made with. And so there's a balance here. However, when those atoms are the elements of the atoms of those elements come in contact with each other, they will react, they will respond to what is happening. And that is when now, you know, we have loss of electrons or gain of electron because some neighboring electron somewhere, some other atom wants the electron more than another element wants it. And when you put those elements together, then you have a reaction. You have bonding taking place and you have a compound being formed. But on a simpler note than that, they just wanted to know this term ease of ionization. It's just a measure of how easily atoms can gain or lose electrons. All right, that's it. I suppose you could add in a chemical reaction. All right. Any questions here, guys?
No, sir.
All right. So remember what we said for that when the radius is very big, the atoms find it easy to lose electrons. But if we change the word lose to gain now, everything becomes the opposite. So in other words, if the atom big, it's easy to lose. When the atom big, if we're using gain, then it's harder to gain. So let me see now. And if we can write it down and let us see if it can make some sense to us here. This is a concept that will carry through bonding. All right. So big atom loses loses electrons easily. But finds it hard to gain. All right, so think about this statement here. So if a large atom is given the task of gaining electrons, it's gonna find it difficult. All right. So that's it. All right, so it's like, look at it this way. Remember when you're little, when you're little, there are you know, anybody used to get some smaller chair to sit in, you know, when you're little, one short chair.
Yes, sir.
Yeah.
Sir, I've never gotten that, sir.
Yeah, only what things happen to you, January. What do you want? Oh God. All the experience was different for everybody, so. All right. You didn't get a little bicycle or tricycle for ride?
Yes, sir, I get a little bicycle,
Yes.
but not a chair.
All right. So watch this now. So it's the same thing as when, all right. So if all right, right now, if the same bicycle is there or tricycle, or the same seat there, Casey, that you used to sit in when you were a 2 or 3-year-old, right? Can you sit in it now?
No, sir.
All right. So here you go. So yeah, that's the same thing. So yeah, I realize it. So for one, when you're younger, it's easier. When you're older, it's harder. It's the same thing. Certain things get harder to do with age, with size, actually. You know, all who used to could have boom flick and them thing there, and split and all these things. When when you get bigger now, you can't. It's harder to do. So problem now with big atoms now is that, you know, in order to gain electrons, the nucleus has to be pulling it, and the nucleus can't pull beyond a certain number of shells. So when you have so many shells now, the pull is very weak, and so therefore the opposite happens. Now, if you read the other part of the question, them say compare magnesium and X in terms of ease and ionization, and Cl and Y in terms of strength of oxidation power. All right, that's oxidation power. So let me use up terms on you. But you know what oxidation power mean?
Oxidation is the loss of electrons,
Oxidation is a loss.
and oxidizing power now, sir, would be
Yeah.
it's the-
Strength of oxidizing power. Oxidation is loss. But here's a catch now. It's not when I be Cl and Y that is losing the electrons, you know. And if you notice there that these anything over here, so these will not be losing. As a matter of fact, everything from here would be gaining electrons, and everything from this side would be losing electrons. So with the periodic table now, you split after the first four groups, you start to draw a little imaginary line then, a little line to show where the gaining and losing kind of separate there. The elements that after silicon, after the side where silicon is, these elements gain electrons. The reason for it, it has to do with how many electrons are on that last shell. And we look at phosphorus. Phosphorus definitely will have 5 if we go through the groups. This is 1, group 2, this is group 3, group 4, and then group 5. Now, when you reach group 5 now, these so phosphorus will have 5 on the outside shell there. 5, which means that it is closer to being full than not full. And so for phosphorus to lose 5 electrons, it's asking a lot. It's better gain the 3 than lose the 5. And so the same thing when it comes next door to sulfur. Well, sulfur would have 6, and you know it could lose 6, but then it would be easier for it to gain 2 more, and so that's what it does. All right, and chlorine is the same thing now. Chlorine, 1 more electron there will give it 7 on the outside shell. Well, it could lose 7, but then it could also gain 1, and so it will gain 1 because that's easier. So that's what I mean by oxidizing power. In this case, it's yeah, oxidation means the loss of electrons, but in this case, the loss of electrons will mean that those electrons will go to chlorine or Y. So whatever Y is lower, and it's the same principle here. Which one you say between Cl and Y, which one will have a bigger atom? Between chlorine and the letter Y, which one's going to have a bigger atom?
Why?
Y. So Y will have the bigger atom. Same thing. But then if we go back to this statement here, big atoms, those is electrons easy, but find hard to gain. And if over here, so it's a gaining territory, and this atom is big, then we see that this Y is at a disadvantage. Everybody see that?
Ah, yes, sir.
Yeah, I mean, it's such a big atom, it can't gain anything. However, if it was over here, where X was, then it will find it easier to lose. But then, over this side, this is the right hand side of the periodic table elements gain. Let's see what space is there. Comparison strength of oxidizing power. All right. So oxidizing power, and MC oxidizing power. So oxidation, if you go back to the definition, is oxidizing power. Oxidation is what you learned before. It's the loss of electrons. All right, and no, when you use oxidizing power, it's a concept that it's more than just the loss of electrons, but it's saying that the element chlorine and whatever letter Y is, it's literally gonna gain it. So the chlorine will gain it, so the element that it react with would be losing the electrons. So that is what this term really means to say. So, and that's why they set this question like this, because they want to see if students understand the concept. Not, to me, I don't think it's an easy concept for students to understand, but I guess with more practice here. But all right, so chlorine, on the other hand, will find it easier to gain. And so let's make that let's put that in terms of information here. So therefore, let's say smaller atoms find it easier to gain electrons because Um, because their nucleus is close to the valence shell, which can accommodate them. So, because their nucleus can, yeah, all right, easily pull an outer electron. So yeah, that's the concept here. All right, so when it comes to these type of reaction, it has to do with the size of the atom and how the nucleus, how close the nucleus is to the electrons. So again, let's see. Well, chlorine is right here. Cl is a stronger oxidizer. And we know oxidizers in nature. Remember that in bleach there is chlorine. So chlorine is an oxidizer. Works very fast. So chlorine is a strong oxidizer, a stronger oxidizer than Y. Explanation, again, due to the size. All right. Chlorine has a smaller atom that allows the nucleus to gain or to pull. And that's the thing, the nucleus is pulling electrons, guys. So that's how they are lost. An element doesn't just lose electrons just like that. They have to be pulled somewhere. So I think that's the concept that CXC wants to send home to every student doing chemistry. All right, the element atom doesn't just lose electrons like that. Something has to be there pulling it. So the chlorine is the oxidizing agent that well, one of the strongest ones in nature. The only thing that's stronger than chlorine in oxidizing or pulling electrons is, well, it's you'd say oxygen and fluorine, those two. So all right, so Cl has a smaller atom that allows the nucleus to pull electrons, all right, from other elements, from other atoms. Easier, all right, than what? Than Y. All right. So pull electrons from other atoms, that part is where the loss comes in. Remember, the oxidation is the loss. So pull electrons. So like chlorine causes the loss of electrons. And then that's why it's called an oxidizer or oxidizing agent. All right, so it's an agent of oxidation. All right, so that's why they use the term oxidizing power. All right, so any questions here, guys?
No, sir.
So
No, sir.
yeah.
Oh, I was wondering if you could hear me because I didn't.
Okay. So again, let's say we have to pay this part some attention, guys. The periodic table would lead into atomic structure, and it would lead also into bonding, which is what they're hinting at here. All right, let me say state one physical property that is similar for both X and Y. and one physical property which is different. Guys, and I'm gonna know this periodic table. All right. So what them say similar and different. What is similar about them? Just looking at it, what would you say? We know what is chemically similar. Because if you look at the periodic table, but then that's why them say physical. Physical.
Sir, they structure them, maybe.
All right. You onto something there, Janari. Somebody was saying something else? Let's keep
Sir, I
going.
want you to go back up on the periodic table.
Okay, sure. Let's go back to on the periodic table. Yeah, here it is. There you go.
Sir, the similar one would be that they would have the same amount of shells.
I know. I was hoping somebody would say that, but that is correct. But they said physical property.
Okay.
Yeah. So and then say chemically that would, if they said chemical property, then that would be
But-
correct. Yes. You're saying-
Don't worry, sir. I was going to say something about ionization, but don't worry, sir.
No, don't go there. It's physical. Physical mean where you can see. Or where your senses can tell you about it. All right. If we're not doing a lab, I don't know if you remember when we did the lab, where the sublimation lab. What substance did we use? Anybody remember?
We use iodine.
Iodine. All right. So if we were to look on the periodic table, which them expect you to know, you're supposed to know all of group 7. I mean, them expect you to know all of group 7. That's the point here. So even though them not say don't identify them, but in reality, they're supposed to know. They're supposed to know. So therefore, in group 7, we have chlorine, we have another element, and we have Y. So if we go into what we should know, then are going back to the periodic table, we would know that this is bromine and this is iodine. All right. Though, what state of matter is iodine? That's a physical property. What state of matter is iodine?
Solid.
Well, yeah, why is a solid? No, so why is a solid? Why is a solid, you know? All right. And in group 2 now, all elements in group 2 are what? What name I give to them?
Alkaline. Earth metals.
Alkaline what?
Earth metals.
Metals, right? So metals are what state of matter?
Solid.
Not solid. So you two of them not solid. That's the easiest thing they could ask here. Both of them solid.
So you know, some there say that they come tell us, sir, what cause me if you mix up the up on the side, we say metal on one side, non-metal. Some there say I must guess and how about this. So
No, but non-metal doesn't mean gas. Non-metal means that it's not a metal.
Sir,
And-
that mix up with, sir.
Yeah, but you can have a non-metal that is solid. So that's where, as we say, group 2 and group 7, they expect you to know all of them. That's why them set this question is a trap. Because they can know the periodic table and know some of it and don't know the details. In the periodic table, you're expected to know all of group 2 and all of group 7. And if you know that, then you won't have any problems here. So state one physical property that is similar for both X and Y. All right. And they are both solid. Different. What was say now? You say the other thing a while ago. What's the difference in the solid now?
Shells.
No, what's the difference in the solid? What type of solid is X? Go back to the periodic table. What type of solid is X?
X is a metal.
Metal. So this is a metal over here, so. And then over here, so is what?
Non-metal.
Non-metal. So that is what they're looking for here. All right, so let's go to that then. All right, so let's scroll down. and complete this. This is physical property that's the same. Is it being solid? Different physical property. So metallic, and that would be X. X is metallic, while Y is non-metallic. Everybody see that?
Yes, sir.
Yes, sir.
All right. We know some metals are going to be shiny. If they want to go into details, physical property, well, I suppose you could say shiny, but then over here, so non-metals tend to be dull. Other stuff, you know, but yeah, when we look at the iodine crystals, when we did the lab, we realized it was a sort of dark gray color. All right, so it was a dull sort of color. So that's the physical property here. Metallic versus non-metallic. If they say that is too chemical a property, we just put shiny and dull to highlight, you know, all metals. Most, well, I think there's, yeah, all metals we could say are shiny. It's characteristic there. Yeah. All right. And then of course we're closing off this question. Element Y will bond with phosphorus to form a compound. All right. Element Y. Well, no, Y is here.
Phosphorus P and element Y. What is element Y? Non-metal, so.
That don't matter. Good.
Type
So
of bond. It could be covalent or ionic or so.
no, it can't be two of them.
No, I was saying R. You have to be one of them.
So which one is it?
Sir, ionic.
Ionic.
Go on. Which way? Hold on. No. Hold on. Kimberly, you say ionic?
Yes, sir, because it's a bond between a metal and a non-metal.
So we're saying element Y is a metal. Element Y up here, so
No.
right up here, so is a
No,
non-metal.
sir. Yes, sir. It's a non.
So this is the same thing I'm talking about. Is phosphorus a metal or a non-metal?
It's a metal.
Phosphorus is a metal. All right, so it means I've been teaching you some wrong thing then, because I remember teaching you that phosphorus is a non-metal.
That I was thinking, sir, because I was wondering.
Yeah, phosphorus is a non-metal. So matches box don't have metal, and that is what they used to make the matches box.
So what it look like, sir? Again,
What?
phosphorus.
It look like the matches, the side of the matches box where you use to strike the fire.
The reddish brown.
Yes, the red part.
Oh. It's just a solid, but not a metal.
Right. So these are two non-metals. So element Y is a non-metal, phosphorus is a non-metal. So when two non-metals combine, what type of bond is that?
Covalent.
Very good. Done this or no? One word. Move on to the next question. Covalent bonding. All right. And then now referring
Sketch a diagram.
Yeah. Okay. Referring to the only the electron in the outer shells of elements. Sketch a diagram to show the bonding between phosphorus and Y. Big boy question is basics, but we'll disclose it off. No, because they never hide some marks. We don't listen. All right. So all right, no problem. That's why is in group 7. Because we identify, say, all right, so why I gonna have 7 on the outer shell? 3 marks, you get 1 mark for showing, say, all right, why we'll have 7, and then you show Y there. All right, let's draw phosphorus now. Probably use a different color here, and just draw this in black. And they say referring to the only, and remember phosphorus is in group 5. If you go back to that periodic table. And if you get any periodic table looking like this, please label it, finish it out with the group and period so you know what you're doing. See phosphorus here in group 5.
Iodine. Why iodine, sir?
Yes, why would be iodine and paper? But they didn't want you guys to reveal that identity, so therefore it's but this is phosphorus, so let's put P there, and there'll be 5 electrons. In fact, let us use a different symbol for the electrons for phosphorus. Even though we're using a different color, they usually say use the dot and cross method. So this is the dot here for phosphorus, just because you're going to use a pen or a pencil in the exam. So, all right, so you get 1 mark for showing this.
So one double band would I go in between them like that?
Double
two
band.
lines
Wait,
or-
no, you two, you're running double band. Calm down. Not ready, not
Purpose that
not yet.
time
Alright.
away station.
Yeah, all right. So everybody see, you get 1 mark for showing what them look like. I'm only doing it this way because I'm teaching it to you. But if you were answer the question, you would just make one go and kill it. All right. The question is now. We have to do some sizing up here. This question now, as I say, need some practice here. Phosphorus is in group 5. How many electrons it going to need to fill up?
Three.
Full up the shell. I need 3.
Phosphorus, sir. Yes,
Mm,
phosphorus
can
would be 3, no, sir.
Need 3. So this is whoa, this question. I love it. It's not an easy question. No. This have more than one answer. The band in between it, because they can band in more than one different way. So how we are do it now? We are do it in a way where you know what gonna happen here, so no. And they want you draw the covalent band. And the only way you could have draw this covalent band now is if you go shear, because you have to go show the shearing of electrons. All right, so I have to go show now. I'm seeing so many different answers here. Let's go here. I'm gonna draw. So anyway, you won't get a mark for this. And then the other 2 marks you get for show the banding. So we just go through with that then. So what you could have here is something like that. I'll deal with the chlorine first. All right, so chlorine with the 7. Yeah, about 3 at least minimum you can have here. So a 3 chlorine. I go share 1 here. So share 1 there. So so then I go have that. All right, so phosphorus there, we have share 1 there. All right, 1 there. So I hate this question though, because it's if you check any book, it's gonna say you have 5 different answers for this. I don't know which one they want here, but we could just try. All right, so phosphorus I go have 5, and you're gonna have something like this. Lone pair, forgive the lone pair here, so you're going to end up with 3. All right, so you're going to end up with something like this. You have to get your mark sheet, because what was CXC thinking here? You basically I'll get 3 chlorine there. 3 chlorine you'd have. All right, notice that for the bonding, for the covalent bonding, are using an overlapping of electrons. And it has to be done in such a way. Let's call this Y. Y is yeah, this is a Y that's in red. I'm gonna explain this to you after. We know that Y is in group 7, but then it's gonna share 1, and covalent bond is all about sharing. So it's gonna share 1, phosphorus are gonna share 1 as well. So this is the answer. This is the answer, guys. If you check it out, phosphorus will end up with 3 electrons, and the 5 where they have. So if you count 1, 2, 3, 4, 5, 6, 7, 8. This is it, you know. This is it. Them say write the chemical formula for the compound form and suggest 2 properties of this compound. Yep.
So
right.
what would be the name given to the combine of phosphorus and iodine?
Phosphorus iodide. It'll actually be phosphorus triiodide. And I think that compound is an unstable compound. So not very, yeah, it might be an unstable compound. Might be explosive too. Wouldn't trust it at all. Anyway, that's besides the story there. All right. So write the chemical formula for the compound form from phosphorus and Y. The formula here, you're going to put P, 1P, how many Ys?
3.
3.
So that's a formula, P and 3 Ys. So there's two properties of the compound. Well, whoa, certainly, because well, the two solid react together, so the result will be solid. Solid at room temperature. Let me say two properties.
So it would be PI, sir, not Y. No, whatever you can find.
Yeah, and that's a good point though. If you write PI3, which technically is the answer, I don't know if CXC would give you the credit for it. I think this gonna be a debate though. I mean, if it was me, I'd give it. But I don't know. Other examiners might not be.
Write down both then, sir. May I write down both?
Yeah, if you write PI3, it shows so you actually know what you're doing. All right, so solid at room temperature, guys. Remember, two solids reacting. The result here would be solid. And them say two properties. How are you going to know properties now? Well, it's going to be a covalent compound. So all right, so it's going to be a covalent compound. So that's what they want. And they expect you to know the properties of a covalent compound. All right, about 5 of them. You know, so.
Could write the color of it too, sir.
No, you can't write color. We don't know what color that going to be. Covalent compound have low boiling point, low melting point. Low boiling point, no melting point. I think that's what they're looking for here. Can dissolve insoluble in water. Covalent compound, most of them can dissolve in water. So insoluble in water. So them say 2. So we're suggesting 2, but we're giving them more than 2 because there's a whole heap. Any questions here?
Sir, wouldn't it be the other way around? Because first when I did it, I was wondering if it wouldn't be the other way around. Up there, the join.
Mm-hmm.
I wonder it wouldn't be iodine, then it would be phosphorus.
You can't go the other way around. You can't go the other way around. Because let's show you what's happening here. Phosphorus have 5, right? Remember, them just ask about oxidizing power of Y. Well, the thing about Y is this, that Y only want 1 electron to fill up the shell. So we agree, so it's in group 7, right?
Yes.
Yeah. So if it want 1, it's going to pull on phosphorus for the 1 electron. And so that is all it wants, 1 electron. It no want no other dealings with phosphorus than just to get the 1 electron. No. Turns out that if phosphorus is going to give away or ease up 1 electron here, well, it also wants to have a full shell. So what it means is that it's going to need 3 more or 2 more of those atoms to balance it out so that it gets 3 atoms of Y sharing. All right, it's just share, each of them share 1 electron with the phosphorus. And so the 5 that phosphorus have, along with the 3 that is shared with Y, would carry the outside shell to 8. And so that would complete the bonding. So that's the way that they would want it to do it for CXC. All right. There's also, and why I say it could go another way, is that you have another case where we could have 5 Ys taking away all 5 electrons. But if you do it that way, it will not be a covalent bond. In fact, that would be an ionic bond. But then that's another story. So I guess this is what CXC want. Well, this question was well set. It's set in such a way that the students, them want to get grade 1, will get it here. Most people would have did from up here, so. And this is really, because you see what it is, it's a topic that most students think, so, oh, easy, man, atomic structure and periodic table, easy. This question was not easy. I wouldn't call this easy. The amount of things we covered tonight just by going through this, it tells you that it's a very deep question. All right, so So this is how you shell down a question, guys, like this. All right. Any questions?
No, sir.
All right, I'm going to send this in the group. Everything copy? Nope. Let's start this up. So all right, here we go. Then copy all of this and send it in the group for you guys to go through. And I think all right, yeah. I think the meeting is being recorded here. And this is atomic structure. Past paper question. All right, let's put here 2013. Doesn't matter really. And there you go. All right, so this should be sent to you. All right, and then the other part of this question. So let me say, can't really take it for granted, but this make we know say we have to go study deep for this topic. As see, and know if you set the exam, then can't set the exam when you're ready, so can't take them for granted. All right. All right, atomic structure. All right, let's see structure and periodic table. All right. All right, possible question. All right, so you should be seeing that. All right. I don't know why the next question is taking so long to send, but hopefully. Oh, I
So
see.
everything finished, sir. You're not sending anything else other than this.
No, I think that's it.
Okay.
I think that's it. Let me see. Yep. All right. So, anybody have a question?
No, sir.
Yeah, good.
No questions.
All right. So as usual, let me send the stream link. I think the video is ready. And yep, it's I'll send the link for that as well. So, all right, that's it then, guys. So as we say, we'll be keeping in touch. If you have questions to keep you occupied here. Not seen any discussion in the group and what's happening. One Saturday, when decides to meet, and that's it. First and the last. I don't know what I'm going with. Anyway. All right, guys. Well, thanks for coming out this evening. Even though a small amount, but hope that you learned something tonight, and you continue with practicing and building the energy towards the exam. Because can't take anything for granted here. All right. So until next class, I will see you. So take care of yourselves and stay safe.
Bye, sir.
All right.
All right.
All right.